Welcome to a brand new video, guys. In this video I'm going to talk about how you can add two polynomials of the same number of terms or the same degree by making use of a linked list. So by making use of the previously learned concepts of linked list, we are going to add two polynomials having the same number of terms or the polynomials which have the same degree. So as you can see, this is the piece of C code I had already written over here for adding two polynomials. So now without wasting any more time, I'm going to jump over to the main function. Inside the main function, as you can see, I had declared three integers, I, m and coefficient, and I had taken the maximum power of the first polynomial from the user and stored it inside the integer m, and then I am taking the coefficient of all the terms of the polynomial, that is the coefficient of the 0th power of x, the first power of x, the squared x and the cubed x, and so on. As many number of terms we have in the first polynomial, I am going to insert the coefficients of all the polynomials making use of the insert at end function. So the insert at end function I discussed in the previous two videos. You can check the previous two videos, which will be on the I button on the top right corner. And after taking all the coefficients as input of the first polynomial, I am going to take the maximum power of the second equation or the polynomial inside the m integer as I had done in the previous case, and then I am going to take the coefficients of all the parts of x of this polynomial also by making use of the insert at end function. So as you can see over here on this line, and then I am going to sum the two polynomials or add the two polynomials by making use of this function, the sum of polynomials. It is accepting two arguments. The first one is the address of the starting node of the first polynomial, and the second one is the address of the starting node of the second polynomial. Now let us move on to see the definition of the sum of two polynomials for same length or the polynomials having the same number of terms over here. So this is the piece of code, or this is the definition for the insert at end function, which I had discussed in the previous two videos. You can check those videos. And this is the traverse function which will be used afterwards we sum the two polynomials. And now this is the function which we want to see. This is the sum of two polynomials function. So the first argument accepts the address of the starting node of the first polynomial, and the second one accepts the address of the starting node of the second polynomial. Inside this function, I had allocated memory space to the pointer p of type struct node, and I have given the first node or the starting node or the first polynomial to p, and then I had done the similar thing to the q pointer over here, but in this case I have assigned the starting node of the second polynomial to q pointer, and then I had declared four integer variables: power, coefficient 1, coefficient 2 and coefficient 3. So what I had done over here is that first of all I had checked the condition. If the starting node of the first polynomial as well as the second polynomial are both null, then we don't have to find any sum because both the polynomials are empty. So we have to print the message that both the polynomials are empty. But if the first polynomial is only empty, then we can print the first polynomial is empty, or else if the second one is empty, then we have to print the second polynomial is empty. But if both the polynomials have some values inside them or have some terms, that is if they have same number of terms, then we are going to use this while loop over here, and this is going to continue until and unless the p pointer as well as the q pointer both reach to the end nodes of the respective linked lists. So by going from node to node, we are going to find out the power of each of the nodes. As you can see over here, we have defined the structured node as coefficient and power. So inside the node we have two integers, coefficient and power. The power variable is going to store the power of each of the x terms, that is each of the variables, and the coefficient is going to store the respective coefficients of each of the powers of x or for each of the terms. So now heading over to the sum of two polynomials function. Inside the for loop, for each of the nodes or for each of the terms, we are going to store the coefficient of the first polynomial as well as the coefficients of the second polynomial inside the coefficient 1 and coefficient 2 integers, and then we are going to find the sum and store it inside the coefficient 3. And after finding the sum of each of the coefficients of each of the nodes or the terms, we are going to insert the power as well as the coefficient or the summed of coefficient by making use of the insert at end function, but with a slight modification. That is, in the previous two videos we saw we only have to insert one integer, but in this case, as we have two integers, that is power and coefficient, we have to insert both of them inside each of the nodes. And then we have to keep on moving on to the next node for each of the two polynomials or linked list. So that was all from the coding part of this implementation by which we can find the sum of two polynomials. In the previous video I showed you how to find out the sum of two polynomials by making use of one array, but in this case I have used two linked lists to find out the sum of two polynomials. But this code only works if the two polynomials are of the same length, or the two polynomials have the same number of terms in them. But for finding the sum of two polynomials having different lengths, we don't know which one is having more number of terms and which one is having lesser number of terms. We have to implement one slightly different function which I'm going to show you in the next part of this video. But now, having shown you the coding implementation, let us jump on to compile this entire code. So this is compiling, and after getting compiled we are going to run. So I have zoomed in a bit so that you can see. So first it is asking us to enter the maximum power of the first equation. So for instance, let us take the first equation is having the degree 2. So it will have three terms: the 0th power of x, the first power of x, as well as the second power of x. So for instance, let us take the coefficients of power 0 of x, that is the constant term, as 1, and the quotient of power 1 of x as 1 also, and similarly the quotient of the second power of x, or the x squared, as 1. Now let us take the degree of the second equation as 2, because we are going to add two similar polynomials, or the polynomials having the same degree. In this case both of them are having degree 2. So now let us take the coefficient of the constant term, or the coefficient of the 0th power of x, as 2, and similarly for the other two terms also the coefficient is going to be 2 only. So as you can see, the first and the second polynomials are this, which I had already entered, and it is saying that the sum of the polynomials are 3 into x raised to 0 plus 3 into x raised to 1 and 3 into x raised to 2. So the polynomial is 3 plus 3x plus 3x square. So if you sum these two polynomials, you will get the exact same result. So this is how you can make use of a linked list and simply add two polynomials having the same number of terms or having the same degree. So that was a short video by which you can easily implement a linked list and find out the sum of two polynomials. So that's it. I hope you enjoyed it until I come up with the next part. If you really like this video, then please like, share as well as comment as much as you can on this video, and also give love and support to all the other videos on my channel. I will come up with the second part of this video very soon. Until then, subscribe to my channel so that you never miss an update from me. So until then, see ya and keep exploring.